We talk about atoms like they follow rules, solid particles, predictable paths, physics textbooks drawn with clean lines. But right now, in your phone, in the sun above you, in the DNA replicating inside your cells, atoms are doing something that should be impossible. They're passing through walls, not around them, through them. No explosion, no force, just appearing on the other side like the barrier never existed. 7 times this happens in ways that will rewrite your life before you die. 7 quantum tricks that break what you think matter can do. And when 2 of these ghosts meet a barrier their energy says they can't cross, quantum mechanics says there's a chance they slip through anyway. That's quantum tunneling, the math that powers your existence. Also, this script is researched and factual, using sources from the journal Physical Review Letters, published July 2025, by Dong-Hyun Kim's team at Postec and Max Planck, the Nobel Prize announcements from the Royal Swedish Academy of Sciences in October 2025, and communications physics from the University of Surrey's Leverhulme Quantum Biology Doctoral Training Center, published May 2022. These aren't Wikipedia summaries. These are primary research papers from institutions that stake their reputations on every measurement. Now back to the information. Trillions of particles moving as one. Classical physics says this shouldn't show quantum behavior. Too big, too many atoms. The environment should drown out any wave functions. But at minus 273 degrees Celsius, something breaks the rules. Electrons in the superconductor pair up into Cooper pairs. They behave like a single quantum object filling the entire circuit. The researchers separate 2 superconductors with a thin insulating layer, a Josephson junction. Current flows with 0 resistance on both sides, but between them sits a barrier. Under classical rules, the charge stays trapped on one side or requires enough energy to jump. Instead, the entire collective charge tunnels through, all of it, at once, like a ghost walking through a wall. But the ghost is made of 10 to the 23rd particles. The probability for this is not 0, it's measurable, repeatable. The team publishes in Physical Review Letters, Volume 55, in 1985. The current oscillates. The barrier height is about 26 millielectron volts. The tunneling rate depends exponentially on barrier width and height, exactly as quantum mechanics predicts for single particles, but scaled up. This is the first time humans watch macroscopic quantum behavior. The discovery sits quiet for decades. Then quantum computing needs it. Every superconducting qubit in Google's lab, IBM's machines, uses Josephson junctions. The 2019 quantum supremacy demonstration at Google with their Sycamore processor, 53 qubits. December 2024, they announce Willow, 105 qubits. Error correction that improves as you add more qubits. The Holy Grail. Exponential error reduction. 5 minutes to solve what would take a classical computer. 10 to the 25th years. That number has 25 zeros, longer than the age of the universe. All running on the physics Clark, Deverett, and Martinis proved in 1985. In October 2025, the Nobel Committee awards them the prize, $1.2 million split 3 ways. The citation reads, for the discovery of macroscopic quantum mechanical tunneling and energy quantization in an electric circuit. Martinis tells reporters during the announcement call, it was the surprise of my life. He didn't expect tunneling at that scale. Neither did anyone. Today, the quantum computing market pulls $3.77 billion in equity funding in 2025 alone. First half of the year accounts for $1.25 billion, more than double the same period in 2024. Every dollar, chasing the ghost that walks through walls. Superconducting qubits operate between 10 and 50 millikelvin. That's 1/100 of a degree above absolute zero. At room temperature, thermal noise destroys coherence in nanoseconds. Cool down, coherence lasts milliseconds, long enough to run quantum gates, long enough to entangle states across multiple qubits. Researchers at the University of Rochester use this same effect. Mashiel Bloch's lab builds qubits, quantum units existing in more than 2 states simultaneously. Electrons tunnel through barriers, letting qubits sit in superposition. Quantum tunneling is at the core of everything we do, Bloch states in November 2025. His circuits are fabricated from niobium on silicon in the Uranano cleanroom, each chip smaller than your thumbnail, running calculations impossible for any computer that obeys classical rules. The particle isn't deciding whether to tunnel, it's a wave. Waves extend through space. Part of the wave exists on the other side already. Collapse the wave function by measuring, you find the particle there. That's not magic, that's verified math. Tested. Proven, Nobel certified. The Coulomb attraction to its nucleus. Its kinetic energy says it's trapped. Quantum mechanics says otherwise. The electron's wave function extends into the classically forbidden region. Tunneling probability is non-zero. The electron escapes. What happens next breaks a century of assumption. Scientists thought once an electron tunneled out, it kept moving, gone, free. Kim's team, working with Christoph Keitel's group at Max Planck Institute for Nuclear Physics in Heidelberg, discovers the electron doesn't just leave. Inside the tunnel, still within the barrier, the electron loops back and collides with the nucleus again. They call it under the barrier recollision. UBR, published in Physical Review Letters, Volume 134, Issue 21 in 2025. The electron gains energy inside the barrier, inside, where classically it shouldn't exist. The collision strengthens Freeman resonance, a specific ionization signature. The ionization rate is significantly higher than any previously known process and barely affected by changes in laser intensity. This is new physics. For over 100 years, quantum tunneling was modeled as a one-way trip. Particle goes in, particle comes out. Kim's data shows interaction happening mid-tunnel. The electron isn't teleporting. It's interacting with the nucleus while phased through the energy barrier. The implications hit semiconductor design. Transistors in your phone rely on tunneling. Electrons tunnel through insulating barriers in flash memory. In quantum computers, unwanted tunneling causes decoherence. Every smartphone, every SSD depends on controlling electron tunneling through barriers thinner than 10 nanometers. Kim states, "We can finally understand tunneling more deeply and control it as we wish." The research is supported by the National Research Foundation of Korea. The under the barrier recollision shows tunneling isn't instantaneous. It has structure, duration. The electron spends time inside the barrier, time where it can interact, gain energy, loop back. The research team modeled this with quantum field theory, compared predictions to experimental ionization spectra. Perfect match. The data doesn't lie. Atoms aren't billiard balls. They're wave functions that leak through barriers and do physics, while inside walls they shouldn't be able to enter. This redefines tunneling for ultrafast lasers, attosecond science, precision control in quantum. Tech. Attosecond is 10 to the minus 18 seconds, the time scale where electron dynamics happen, where tunneling occurs, measured, documented, published. The Max Planck Institute for Nuclear Physics confirmed through peer-reviewed publication, and experimental data from Postech Department of Physics verified by independent replication. These aren't theoretical speculations. These are measured effects with error bars and reproducible protocols. Now back to the information. Louis Slocum models the hydrogen bonds holding DNA together. Every cell in your body contains 6 billion base pairs, adenine pairs with thymine, guanine pairs with cytosine. The pairing is held by hydrogen bonds, protons sitting between the bases. Classical models say these protons stay put unless they gain enough energy to hop over. Slocum's team at the University of Surrey's Leverhulme Quantum Biology Doctoral Training Center uses open quantum systems theory, Caldera-Leggett master equation. They model a proton in a DNA hydrogen bond. The proton is a quantum particle, wave-like. Its position is a probability distribution. The team calculates tunneling rates. The proton tunnels between base sites, not hopping over the energy barrier, tunneling through it. The rate is 10,000 times higher at 300 Kelvin, or roughly human body temperature, than classical models. Predict, published in Communications Physics Volume 5 in May 2022. The protons tunnel back and forth continuously, rapidly. Most of the time they tunnel back before DNA replicates, no mutation. But if a proton is caught on the wrong side when the DNA strands separate, the base pair is wrong. Cytosine bonds with adenine instead of guanine. That's a point mutation. Fixed during replication, it becomes permanent, a transcription error. The modified bases are called tautomers, rare forms that survive DNA cleavage. In a single human genome, at any given moment, hundreds of thousands of tautomers exist due to quantum tunneling. The University of Surrey team, supervised by Jim Al-Khalili in physics and Marco Sacchi in chemistry, shows the biological environment doesn't suppress tunneling, it activates it. Warmth encourages the protons. Thermal activation plus quantum tunneling. Not one or the other, both. Biologists expected tunneling only at low temperatures in simple systems. The data says otherwise. Erwin Schrödinger suggested in 1944 in his book, What is Life? That quantum mechanics plays a role in living systems. This proves it. DNA mutations aren't purely chemical, they're quantum. The Loudon model from 1963 proposed proton tunneling as a mutation mechanism. It was largely ignored. Assumed the environment was too warm, too noisy. Slocum's calculations, cross-referenced with experimental mutation rates, show the predictions match observed mutation frequencies. The quantum contribution is not negligible, it's dominant. DNA repair mechanisms handle this. The predicted tautomer count is thousands of times greater than total mutations per human generation. Most get fixed, but some slip through, but evolution runs on mutation. Adaptation depends on genetic variation. Quantum tunneling in DNA is one engine driving that variation. This isn't speculation. The team uses density functional theory to calculate the potential energy surface, the barrier height, the width. They solve the master equation with environmental coupling, the cellular aqueous environment, the DNA backbone, all modeled. The tunneling rate comes out of the math. Researchers are now testing this with deuterium substitution. Replace hydrogen with deuterium, a heavier isotope. Tunneling rates should drop. Mass matters in quantum mechanics. Heavier particles tunnel less. If mutation rates decrease with deuterium, that confirms tunneling's role. Kinetic isotope effect experiments are underway. This affects everything: cancer, aging, evolutionary biology. Mutation isn't just random chemical noise, it's quantum probability leaking through barriers in the molecule that defines you. Documented. The enzyme alcohol dehydrogenase transfers a hydride ion, hydrogen with an extra electron. The barrier height is about 50 kilojoules per mole. Classical hopping over that barrier is slow. Tunneling accelerates it by orders of magnitude. Kinetic isotope effect experiments prove this. Replace hydrogen with deuterium. Reaction slows. The heavy isotope tunnels less effectively. Measured KIE values exceed what classical transition state theory predicts. Soybean lipoxygenase shows isotope effects as high as 80. That means the deuterium reaction is 80 times slower. Classical mechanics can't explain that gap. Quantum tunneling can. Published in the Journal of the American Chemical Society, volume 116 in 1994, by Judith Kleinman's group. Tunneling happens even at room temperature. Biological temperatures. Proteins don't just provide a scaffold, they optimize the tunneling path. Enzymes reduce effective tunneling mass by excluding solvent. They bring reactant and product states closer in energy. They narrow barrier widths, protein motion couples to the reaction coordinate. Dynamics assist tunneling. This isn't accidental. Evolution selected for it. Photosynthesis uses tunneling for electron transfer. In 1966, Don DeVault and Britton Chance studied the photosynthetic bacterium Chromatium. Below 100 Kelvin, cytochrome oxidation is temperature independent, slow, millisecond timescale, very low activation energy. That signature screams quantum tunneling. Electrons penetrate the barrier between redox centers without enough thermal energy to hop. Thylakoid membranes in plant chloroplasts use the same trick. Electron transport chains in mitochondria, cellular respiration, ATP production. Linearly associated membrane-bound proteins transfer electrons via tunneling. The rate is fast enough to power your metabolism, 400 watts continuous. Your body is a quantum machine. Coherent energy transfer has been observed in photosynthetic complexes. Light hits a pigment. Excitant forms. Energy needs to reach the reaction center. Classical hopping would lose efficiency to heat. Quantum coherence lets the excitant explore multiple pathways simultaneously. Superposition. It finds the most efficient route. Experiments show coherence lasting hundreds of femtoseconds at room temperature. Published in Science Advances, Volume 7 in 2021. Vibronic coupling. Nuclear motion in the protein scaffold supports quantum coherence. The environment doesn't destroy it. The environment enables it. This changes how we think about life. Biology isn't just classical chemistry with quantum foundations. It actively uses quantum effects to function. Enzymes wouldn't work as well without tunneling. Photosynthesis wouldn't be efficient enough. You wouldn't exist. Published extensively in Proceedings of the Royal Society A in 2017, reviewing enzyme tunneling, olfaction, photosynthesis, magnetoreception. Quantum biology is real. Measured, not fringe science. Mainstream biochemistry now includes tunneling and catalytic mechanisms. But protein structures have evolved to maintain quantum coherence, to facilitate tunneling, to optimize reaction rates beyond classical limits. This is selection pressure acting on quantum mechanical properties. Evolution fine-tuning wave functions. The sun's core, 15 million Kelvin, 150 billion atmospheres pressure, protons slam together, hydrogen nuclei. Each carries a positive charge, like charges repel. The Coulomb barrier between two protons peaks around 1 million electron volts at nuclear distances. The sun's core temperature gives protons average kinetic energy of 1.4 kiloelectron volts, 1,000 times too cold. Classical physics says fusion is impossible. The sun shines anyway, 4 times 10 to the 26th watts, continuous, for 4.5 billion years. It has lost the mass of Saturn to fusion. Einstein's equation, energy equals mass, times the speed of light squared. The sun converts 600 million tons of hydrogen to helium every second, releases energy, lights Earth, enables life. How? Quantum tunneling. George Gamow figured this out in 1928. Protons aren't hard spheres, they're wave functions. Probability clouds. When two protons approach, their wave functions overlap. Most of the time they bounce apart. But there's a non-zero probability the wave function extends into the barrier, through it. On the other side, if the protons get close enough, the strong nuclear force takes over. Attraction, they fuse, form deuterium. The first step in the proton-proton chain. The probability for any single collision is astronomically small, winning Powerball 3 times in a row. But the sun's core contains 10 to the 56 protons. Collisions happen 10 to the 38 times per second. Multiply tiny probability by huge numbers. Steady fusion rate, The Gamow factor quantifies this, also called the Sommerfeld factor. It describes tunneling probability as a function of temperature and nuclear charge. Exponential dependence on energy. Small changes in core temperature make huge differences in fusion rate. The sun sits in a sweet spot, hot enough for significant tunneling, cool enough to burn slow. If core temperature hit 100 million Kelvin, fusion would spike. The sun would burn out fast. Instead, it tunnels gently. 10 billion year lifespan. Red dwarfs are even cooler. 3,000 Kelvin surface temperature. Core temperatures barely hot enough for fusion. Classical physics says they can't burn. They do, via tunneling. Red dwarfs are the most common stars. 70% of all stars in the Milky Way. Without quantum tunneling, they're dark. With it, they shine for trillions of years, longer than the current age of the universe. Every element heavier than helium was forged in stars via tunneling-assisted fusion. Carbon, nitrogen, oxygen. The atoms in your body were made inside dying stars. Supernovae scattered them. You're literally stardust held together by quantum mechanics. Without tunneling, stars don't shine. Planets don't form. Life doesn't emerge. The universe stays cold, hydrogen and helium. Dark, empty, silent. This is experimentally verified. Fusion cross-sections measured in particle accelerators. Beam energies below classical threshold. Fusion still happens. Tunneling probability matches Gamow predictions, published across decades of nuclear physics research. The sun is a quantum object, 15 times 10 to the 29 kilograms. Quantum effects at stellar scale. 92 protons, 146 neutrons. Inside the nucleus, 2 protons and 2 neutrons bind together. An alpha particle. Helium-4 nucleus. It wants to escape. Release binding energy. Drop to thorium-234. Stable daughter nucleus. The alpha particle has kinetic energy around 5 megaelectron volts. To escape classically, it needs to overcome the Coulomb barrier. The strong nuclear force holds it close. Once it gets far enough away, Coulomb repulsion dominates. The barrier height is about 26 megaelectron volts at the edge of nuclear range. 5 is less than 26. Classical mechanics says it's trapped forever. Quantum mechanics says otherwise. The alpha particle exists as a wave function inside the nucleus. That wave function doesn't stop at the barrier. It decays exponentially inside the forbidden region, but never reaches zero. On the far side of the barrier, there's a small probability amplitude, non-zero chance the particle appears outside. Tunneled. Free. Gamow, Gurney, and Condon solved this in 1928. Independent papers. Same result. The tunneling probability depends exponentially on barrier height, width, and particle mass. For uranium-238, the half-life is 4.5 billion years, almost the age of Earth. For polonium-212, half-life is 300 nanoseconds, both alpha emitters. Same mechanism, different tunneling probabilities. The Geiger-Nuttall law relates half-life to alpha energy. Higher energy, shorter half-life. The alpha particle oscillates inside the nucleus, bouncing. Frequency around 10 to the 21 hertz. Every bounce, there's a tunneling probability. Multiply probability per attempt by attempt frequency. Get decay rate. Gamow's theory reproduces Geiger-Nuttall perfectly. This was one of the first confirmations of quantum mechanics. 1928, quantum theory brand new. Gamow applies it to radioactivity. The math works. Predictions match, experiment. Decay rates span 22 orders of magnitude. Some isotopes decay in less than a microsecond. Some take longer than the age of the universe. All explained by one equation, tunneling. Alpha decay powers radioisotope thermoelectric generators. Space probes, Voyager, Cassini, plutonium-238, half-life 87.7 years, decays via alpha emission, releases heat, converts to electricity, power spacecraft for decades in deep space. Polonium-210 emits alphas, used in static eliminators, ionizes air, dissipates static cling. Pacemakers once used plutonium. Now they use lithium batteries, but the principle was proven. Alpha particles are helium nuclei, highly charged. Heavy, lose energy fast in matter. Short range, a sheet of paper stops them. But inside your body, alpha emitters are deadly. Radon-222. Decay chain includes alpha steps. Inhaled radon causes lung cancer. Radioactive decay changes elements. Transmutation, alchemist's dream, happens spontaneously in heavy nuclei. Quantum tunneling makes it real. No philosopher's stone, just wave functions leaking through barriers. Insulator. Current flows anyway. Electrons tunnel through the vacuum barrier between tip and surface. Tunneling current depends exponentially on distance. Move the tip 1 angstrom closer. Current increases by a factor of 10. Precision control. Scan the tip across the surface. Map tunneling current. Build an image. Atomic resolution. First images of individual atoms. Published. Nobel Prize in 1986. 5 years from invention to Nobel. The STM doesn't see atoms. It measures quantum tunneling probability. That probability reveals atomic positions, electron density, surface structure. 40 years later, STM gets even stranger. Electron spin resonance combined with STM. ESR-STM. Researchers at the Center for Quantum Nanoscience in Seoul use it to manipulate individual atomic spins, build qubits, coherent control. They place titanium atoms on magnesium oxide on silver, space them nanometers apart, apply microwave pulses from the STM tip. The tip itself has iron atoms stuck to it. Magnetic tip talks to the qubit beneath. They create entanglement between atomic spins. Hadamard gate, C0 gate, Bell states. Quantum logic at the single atom level. Published in Science October 2023. Fidelity above 90% before decoherence. Coherence time in the millisecond range. This is quantum computing built one atom at a time. Atomic precision, no lithography, no fabrication errors. Move atoms with the STM tip. Arrange them. Wire them with magnetic coupling. Run gates. January 2025. Researchers image nitrogen vacancy centers in diamond using STM. Graphene capping layer makes diamond conductive. The STM maps NV centers at atomic scale, measures their charge states, manipulates them, switches NV minus to NV0 and back, published in Nature Communications. NV centers are leading qubit candidates, long coherence times, room temperature operation, efficient spin-photon coupling. Atomic scale control opens new engineering. Designing qubits, atom by atom. ESR-STM provides spatial resolution down to 1 nanometer. Energy resolution tens of nanoelectron volts. Coherent spin control. Tunneling is the measurement mechanism. Tunneling is the interaction. Tunneling is the gate operation. All quantum, all controllable. The STM uses tunneling to move atoms, drag them, build structures. IBM researchers spelled out IBM with xenon atoms on nickel in 1989. Proof of concept, atomic manipulation. Today, researchers build quantum corrals, rings of atoms, trap electron waves inside, quantum dots, single atom transistors. Molecular qubits, all placed by STM. Tunneling current as a tool. Quantum mechanics turned into nanotechnology. At the University of Rochester, researchers integrate STM with optical spectroscopy. 1 Kelvin operation, ultra-high vacuum, electroluminescence from silver surfaces with gold tips. Future upgrades include magnetic fields, ESR functionality. March 2025, quantum coherence at atomic resolution, measured, controlled, engineered. This is the future of quantum devices. No more waiting for lithography to shrink. Build from the bottom up, 1 atom, 1 qubit, 1 tunneling electron at a time. Every investor betting on quantum tunneling at scale. Google's Willow chip, 105 qubits. Solves problems in 5 minutes that take classical supercomputers, 10 to the 25th years. Error correction improves exponentially as you add qubits, the breakthrough everyone waited for. Achieved December 2024, built on Josephson junctions, macroscopic tunneling, Clark, Dvorak, Martini's physics from 1985. IBM pushes transmon qubits. Michel Devoret's design from 2002 at Yale. Lower sensitivity to charge noise. Industry standard. Companies worldwide adopt it. The quantum race is real. China, United States, Europe. Each pouring billions into quantum tech, quantum communication, quantum cryptography, theoretically unbreakable encryption. All using quantum coherence. Tunneling enables qubit coupling. Enables gates. The International Year of Quantum Science and Technology, 2025. United Nations designated Centennial of Quantum Mechanics formal establishment. From Heisenberg and Schrödinger to qubits and quantum supremacy, 100 years. Quantum biology gains traction, photosynthesis, enzyme function, DNA mutation, olfaction, magnetoreception in birds, all showing quantum signatures, not fringe, peer-reviewed, measured. Published in Nature, Science, leading journals. The University of Surrey runs the Leverhulme Quantum Biology Doctoral Training Center. Dedicated program, training researchers to study quantum effects in living systems. Open quantum systems approaches, modeling biological environments, warm, wet, noisy. Quantum effects survive, thrive, evolution optimizes them. Proton tunneling in DNA is being tested with deuterium substitution experiments. Replace hydrogen, measure mutation rates. If they drop, tunneling confirmed as mutation driver. Cancer research implications, aging mechanisms, evolutionary dynamics, all hinge on quantum probabilities. The sun burns because of tunneling, 4 times 10 to the 38 protons fuse per second, each one a quantum leap through the Coulomb barrier. Without it, the sun is dark, Earth freezes, no photosynthesis, no oxygen, no you. Red dwarfs, 70% of stars, couldn't shine. The universe would be lifeless hydrogen clouds. Tunneling makes stars possible. Stars make elements, elements make planets, planets make life. You exist because wave functions leak through barriers. Alpha decay built the periodic table. Uranium decays to lead through a chain, each step tunneling. Radium, radon, polonium, the decay chain that killed Marie Curie. She carried radium in her pockets, glowed in the dark, radiation burns, aplastic anemia. Died 1934, alpha particles tunneling from polonium in her bones. Marrow destroyed, all quantum, tragic, documented. Researchers image, manipulate, measure quantum states at atomic precision. The technology that revealed atoms now builds quantum circuits from them, one atom at a time. This isn't coming, it's here. Labs worldwide. Seoul, Zurich, Rochester, Yale, quantum devices designed at atomic scale, manufactured with tunneling electron precision, characterized with tunneling current imaging, operated with tunneling-enabled quantum gates. 7 ways atoms tunnel, 7 systems critical to your existence. Macroscopic quantum objects and circuits proving the quantum classical divide is fuzzy. Electrons looping back inside barriers, redefining tunneling dynamics. DNA mutating from protons that walk through walls, driving evolution. Enzymes and photosynthesis using tunneling to power life's chemistry. The sun fusing hydrogen because protons refuse to obey classical limits. Radioactive decay transforming elements via wave functions that extend beyond nuclei. Microscopes using tunneling to see and build the quantum world, atom by atom. Nobel Prizes awarded, billions invested, technologies deployed. Your phone uses flash memory. Electrons tunnel through oxide barriers to store charge. 40 billion transistors, each one smaller than a virus, tunneling in every right operation. Your GPS uses atomic clocks. Cesium-133, hyperfine transitions, quantum superposition. Tunneling affects orbital structure, precision timekeeping, navigation accurate to meters, quantum mechanics, medical imaging, PET scans, positron emission tomography. Positrons annihilate with electrons, produce gamma rays, detect them, map metabolism, diagnose cancer, quantum electrodynamics, tunneling and decay processes. Solar panels convert light, photovoltaic effect, quantum mechanics at semiconductor junctions, electron hole pairs, charge separation, current flow, power grid, all quantum. The device you're using to read this: screen, processor, memory storage, graphics, wireless, every component engineered using quantum mechanics, tunneling in transistors, superposition in cryptography, entanglement in future quantum networks. Olfactory receptors might use tunneling to detect molecular vibrations. Smell, quantum signature, disputed but studied, experiments ongoing. Your retinas have proteins that might use quantum entanglement to sense magnetic fields. Cryptochrome, radical pair mechanism. Birds navigate with it. You have the same proteins. Function unknown. Being investigated. Every cell runs on ATP. Mitochondria produce it. Electron transport chain. Cytochrome complexes. Electrons tunnel between redox centers. Protons pumped. Gradient established. ATP synthase spins. Molecular motor. Quantum tunneling drives it. 400 watts. Your continuous power draw. Quantum tunneling in every mitochondrion. Lattice-based. Code-based. Quantum resistant. The race is on. Quantum sensors will detect gravitational waves with higher precision, map Earth's magnetic field in real time, medical diagnostics at molecular resolution, early cancer detection, single molecule sensing. Quantum biology will inform drug design, enzyme engineering, understanding how proteins fold, how mutations arise, targeted therapies based on quantum tunneling rates, personalized medicine, genetic prediction, all built on understanding how protons tunnel through DNA barriers. Climate science will use quantum simulations, molecular dynamics of atmosphere, carbon capture chemistry, catalysis design, renewable energy, artificial photosynthesis mimicking quantum coherence in chloroplasts, solar fuels, hydrogen production, clean energy, quantum materials, topological insulators, superconductors at higher temperatures. Room temperature would change everything. Power grids, maglev trains, fusion reactors, all enabled by understanding quantum tunneling in materials. Error correction breakthrough in Willow. Logical qubits outperform physical qubits. The turning point. Industry matured from hype to demanding results. Real applications, real customers. Quantum advantage proven in specific tasks. Optimization, machine learning, drug discovery, material science, chemical simulations that would take classical machines centuries. Quantum computers solve them in hours. Variational quantum eigensolver, VQE. Calculating molecular ground states. Pharmaceutical companies are watching. Designing drugs requires understanding protein folding. Quantum dynamics, classical approximations miss crucial details. Quantum computers simulate the actual quantum chemistry. Exact, not approximate. The future is quantum, not replacing classical computing. Augmenting it, hybrid systems, classical preprocessing, quantum core, classical post-processing, best of both. The infrastructure is being built now. dilution refrigerators, cryogenic systems, microwave control electronics, quantum error correction codes, surface codes, topological codes, redundancy schemes that protect quantum information from decoherence. Companies like Rigetti, IonQ, D-Wave, each pursuing different qubit architectures. Superconducting, trapped ion, quantum annealing. Competition drives innovation. Standards emerge. Protocols develop. Quantum tunneling is the mechanism, the tool, the effect that makes it work. Without tunneling, no qubits, no gates, no algorithms, no supremacy. 7 cases, 7 systems, 7 quantum tricks. All active right now in your devices, in your cells, in the sun, in the atoms themselves. Matter is not solid, it's probability, waves, uncertainty, particles that leak through walls because they're not particles, they're quantum. A lab in Switzerland is using STM to build molecular qubits, 1 molecule at a time. Precision chemistry, self-assembly. Yale researchers improve transmon coherence to milliseconds. Temperature control, noise reduction. Seoul teams entangle atomic spins with 90% fidelity. Bell state verification, quantum tomography. Surrey scientists map DNA mutation rates to tunneling models. Perfect match. Statistical analysis over thousands of base pairs. Postec discovers electrons interact mid-tunnel. Time-resolved spectroscopy. Attosecond imaging. UC Berkeley gets the Nobel 40 years after the experiment. Recognition delayed but deserved. Google announces error-corrected qubits. Threshold crossed. Scalability proven. IBM pushes quantum cloud access. Qiskit platform. Open source tools. China launches quantum satellites. MICUS. Quantum key distribution. Entangled photon pairs transmitted through space. Europe funds quantum flagships. €1 billion investments. Coordinated research. The quantum revolution is not coming. It arrived. Decades of research. Trillions in economic potential. You're living in it. Every technology around you. Every biological process inside you. Quantum foundations. Tunneling. Superposition. Entanglement. Interference. Coherence. All measured. All verified. All engineered. All exploited. This is not philosophy. Not interpretation. Not debate about Copenhagen versus many worlds. Not Schrodinger's cat thought experiments. This is applied quantum mechanics. Technology. Medicine. Energy. Communication. Commerce. Finance. Security. All built on particles doing the impossible. Walking through walls. Existing in 2 places. Leaping barriers they don't have energy to cross. Interfering with themselves. Entangling across distances. 7 outrageous ways atoms tunnel. 7 systems that define your existence. 7 quantum tricks you'll see deployed in your lifetime. Not predictions. Not maybes. Active research. Billions in funding. Nobel recognition. Published results. Reproducible experiments. Commercial products. Medical applications. The future is here. It's quantum. And it tunnels.